Hi everybody, it's Miss Phoebus again, and it's lesson 5, and this is about dimensional analysis and proportions. Make sure you're taking notes. Alright, we're going to go back to the vocabulary, the words I know and the words I don't know, and here are your vocabulary words for today. Conversion factor, dimensional analysis, proportion, ratio, and scale factor. Which ones are the words you know, and which are the words you don't know? All right, so let's look at these. A lot of this goes back to fractions. So we are looking at conversion factors as a ratio that represents the relationship between two different units. The conversion factor is always equal to 1. So we know that there are 7 days in 1 week, or we should, 60 seconds in 1 minute, and 12 inches in 1 foot. And those are just some examples of conversion factors. And those are true statements. Those are things you should have picked up along the way in your elementary school lives. Dimensional analysis is a problem-solving method that uses the fact that any number or expression can be multiplied by 1 without changing its value. And we're going to use those conversion factors in our dimensional analysis. And the goal is to make units cancel so that certain units survive. And we can basically do some conversions. Proportion is a statement that two ratios are equal to each other and can be written it can be written in 2 ways, as fractions or using a colon. We're going to deal with the fractions, but the colon kind of, you can rewrite it and change it if you needed to. We're going to focus on the fractions. Ratios. They are a comparison of two different values. Usually we compare them by division, and usually in English we use the word per to show that we are creating ratios. But we can also write a ratio using a colon, like 8 boys for every 5 girls. A scale factor is a ratio between two different sets of measurements. We often use scale factors when comparing a drawing or a model to a life-size figure. All right. So, your learning goals for this lesson. I can convert between different standards of measurement. You'll be able to perform dimensional analysis. Now, dimensional analysis, kind of like literal equations, not exactly like literal equations, like that's a different kind of math. But it tends to be something that students struggle with. And I'm going to encourage you to focus on the units. So please kind of take note of the things that I'm stressing, and if I keep repeating myself over and over again, that means that it's probably worth paying attention to that aspect of it. But it is something that we will have to work on. We're also going to write equations and use cross multiplication to solve real-world problems involving similar figures in scale. And then we're going to crank it up a notch. We'll break out the algebra some more. We'll wrap this up with solving some complex proportions. Again, one of my favorite things is taking problems that look so difficult and turning them into such an easy idea. All right, so we are going to use units. This is our Tennessee State Standards, by the way. We're going to use units as a way to understand problems and to guide to the solution of multi-step problems. That's going to be the dimensional analysis part as well as the scale factor part. And then we are also going to create equations in one variable and use them to solve problems, as well as we're solving for one variable equations. All right, so this gets into the unit conversion and dimensional analysis portion. We have things that are true up here. 1 foot is 12 inches, 3 feet is 1 yard, 1 mile is 5,280 feet. The empirical to standard conversion, 1 inch is 2.54 centimeters. Okay, so that allows you to cross over into going from centimeters to meters and things like that. A pound is 16 ounces, a ton is 2,000 pounds, a pound is 454 grams, 1 gallon is 4 quarts, and so on. So we're just looking at all of these different things that are true. Now, I have this box down here that talks about different standard notations, kilo, deci, and all of that stuff. Basically, units of conversion, as far as if you see this word, then it means, like centimeter is 0.01 meter, and millimeter is 0.001 meter. So you can use the wording to help you in that kind of sense of the conversion factors. But there are other conversion factors, and they may come up. I do have a big box here. Sometimes it's just kind of out of necessity that you will need to figure out a conversion factor. So the best way to do that is Google is a great source of information. Now, if I'm telling you, hey, I want you to figure out how many cups are in 97 gallons or something like that, I don't want you to go straight to Google and type in how many cups are in 97 gallons. I want you to be able to do that math. But if you don't know any conversion factor, let's say you didn't know 1 inch was 2.54 centimeters and you were trying to convert how many miles into how many kilometers and you didn't have that conversion factor, you could use Google, you could use your resources. Start with converting your teacher's age, that would be my age, from years into seconds. Now, it is not my birthday. My birthday is in April, so you do not know my age exactly, but we're just going to go based off of years. Let's pretend my birthday's today. Hey guys, my birthday's today, and I am 40 years old. Yes, I'm that old. All right, so what we're going to do is we're going to convert to seconds. So I'm going to encourage you to follow this setup, and I'm going to keep doing this setup. I'm going to encourage you to do it, and it can get long. We can go out several times. But the other thing I need you to do is I need you to make sure you've got your units. Okay? So we're going to start with 40 years. Write that down. And what we need to do is we need some conversion factors, a little times and a little fraction bar. There are 365 days in 1 year. Now you may say, Ms. Phoebus, why did you write it like that? Well, I have a numerator and I have a denominator, and technically this is over 1. So anything, even units, that I have in a numerator can cancel with a unit in a denominator. So what I have here is my years can cancel. And now when I multiply 40 times 365, I will have however many days there are in my age. But I'm not done. So this is where the units lead you to the correct answer. I'm not done. My answer is now in days. Once I multiply those, I don't want days, I want seconds. So we know that there are 24 hours in a day. Because days are on top in the in that second fraction bar, I'm going to put 1 day in the bottom. So I have days in the numerator, day in the denominator. And then I know that there are 24 hours in a day. Days on top cancel with days on bottom. All right, I'm going to try to write a little bit smaller. I got a little too big in my writing. I know I got to go from hours to minutes and minutes to seconds. So some people know how many seconds there are in an hour, but if you don't, that's okay. I know in 1 hour there's 60 minutes. Getting ahead of myself, trying to go to seconds. Hours cancel with hours. So if I multiplied 40 times 365 times 24 times 60, that would be how many minutes old Miss Phoebus is. And I want to do in 1 minute, there are 60 seconds. And my units, remember they have to cancel. 1 on top, 1 on bottom. And then now I have everything set up. So it's because everything on top, or pretty much everything is on top in these fractions, I'm just going to multiply them. If I had a number on the bottom, I would divide. So I'm going to take 40 times 365 times 24 times 60 times 60. Oh my goodness, people. I am too old for this. I'm over this number of seconds. 1,261,440,000 seconds, ladies and gentlemen. Yes. Oh, I forgot my units. That is how old I am, ish, right? I'm a little bit older than that, a couple months older than that. Just tack on some more seconds. All right, so the setup is key, and that is really what we're learning. We're learning the setup, and we're learning on how to figure out to set our units up correctly. And you may be like, Miss Phoebus, this is silly. I don't need this setup, but I will guarantee you when you take chemistry, you are going to be glad that you have learned this process because they do it in chemistry a lot. All right, so let's do number 2. We're going to convert, let's pick a number. 22 quarts into ounces. So what you need to do is you need to go back and you can look at the conversion factors if you want. You do have the slideshow available to you, so if you want to pull that up in another tab so you can access that, you may want to write some of them down in your notes. 22 quarts, and I'm going to go ahead and abbreviate. Quarts is QT. You put QTS if you want to. And what I want to do is I want to go from quarts. If you go back and you look at that table, we can go from quarts to pints to cups to ounces. So in a quart, there are 2 pints. So in 1 quart, there are 2 pints. And the quart goes on the bottom because the quart up here is in the numerator. So quart over quart, cancel. And now I have the number of pints. Well, there are 2 cups in a pint. So in 1 pint, there are 2 cups. I didn't abbreviate that one. Pints and pints cancel. And then in 1 cup, there are 8 ounces. Abbreviated OZ. Now that all my units have canceled, and I can't cancel them if they're like both in the numerator or both in the denominator. One has to be in the numerator, the other has to be in the denominator. And then we're going to do 22 times 2 times 2 times 8, and I'm just shoving it in a calculator. I get 704 ounces. Make sure you include your units. All right, let's look at number 3. We're going to convert 17 tons into grams. How many grams? So we're going to something really big. Tons are really big. And we're going to grams. Grams are really tiny. So we should expect a big number. Anytime you go from something really tiny and convert it to something big, we should end up with a really small number. All right, so 17 tons to grams. So I'm going to write 17 tons. And tons can convert to pounds. There are 2,000 pounds in 1 ton. There we go. Now, we are going to have to go from pounds to grams. And if you go back and look, 1 pound is 454 grams. So pounds are on top with the 2,000. I'll put 1 pound down here in the denominator, and then 454 grams. I'm going to grab my calculator and do 17 times 2,000 times 454. And I get, looks like 15,436,000 grams. All right, let's look at 4. 10,000 feet to kilometers. So we got a big number, 10,000. 10,000 feet. And we're going to convert it into kilometers. So what we need is to go back and look at that unit of length. And the best thing I've got is to go from inches to centimeters, that there are 2.54 centimeters in an inch. So I need how many inches are in a foot. In 1 foot there are 12 inches. And then that means that in 1 inch there are 2.54 centimeters. Oh, let me go back and cancel my units. Cancel, cancel. 1 on top, 1 on bottom, so I'm left with centimeters. And then there are 100 centimeters in 1 meter. That's what the centi means, and we use the cent in like the terms of cents. We have 100 cents in our dollar. And there are 1,000 meters in 1 kilometer. That goes back to that kilo. So meters cancel, and now I'm to kilometers. Now if you notice, I've got two numbers in the denominator of that fraction. So what I'm going to do is I'm going to multiply my 10,000 times 12 times 2.54. I'm going to multiply all those together. Technically, you're multiplying also by 1 and by 1, but hopefully by now we know if we multiply by 1, it doesn't change anything. So once I multiply by all those things in the red box, multiply them all together, then I'm going to divide by these guys. Divide by 100, and usually I hit enter after that, and then divide that answer by 1,000. So the rest of this is just getting in the calculator, but doing it in a way that we're going to get the correct answer. So 10,000 times 12 times 2.54. I'm going to divide that by 100, hit enter, and then divide that by 1,000 and hit enter. And I get 3.048 kilometers. Now, let's talk a little bit about how many decimals we should give. If it ends pretty quickly, like within 3 or 4 digits of the decimal, the more decimal places you have, the more accurate you are. If it goes on like off the screen and it just keeps going, then if you're not told, you can do 2 or 3 digits and probably around to the nearest hundredth or thousandth. But usually I tell you, you don't want to round too early. You don't want to call this just 3 kilometers because it is a little bit more than 3 kilometers. All right, so here are yours, and you can go back and you can look at the slideshow if you like. Let me see if I can maybe, let's see, we need pounds to kilograms. So if I tell you that 1 pound equals 454 grams, and then there are 1,000 grams in a kilogram, that'll help. In 1 kilogram. And then I think you're good on seconds and days because we use that quite a bit. So pause the video, try to answer these 2 questions. Alright, you should be back. You should have paused the video, and now we're going to do 3.54 kilograms, and we're going to convert that into pounds. So I know 1 kilogram is 1,000 grams. I need to get rid of kilograms and pick up grams. Then I can go from grams to pounds. So 1 kilogram is going to go on the bottom. 1,000 grams is going to go on top. We want the kilograms to cancel. And now we have grams. Then we're going to multiply because we don't want grams. We don't want to know how much the baby is in grams. We want to know in pounds. But we're almost there. We know that there are 454 grams. That goes on bottom because there's grams on the top. Grams on the top, grams on the bottom. And there are 454 grams in 1 pound. So then now my units are all canceled with the exception of pounds. And I am going to do 3.54 times 1,000. And when I'm done with that, because the 454 is in the denominator, I will divide by 454. So 3.54 times 1,000. And then divide that answer by 454, and we get 7.797. I'm going to go with 7.8 pounds. So almost 8 pounds. For 2, how many seconds are there in 2 days? So we're going to start with 2 days. And remember, the goal is to get units to cancel. We want 1 on top, 1 in the numerator, and the same unit in the denominator. So we're going to go from days to hours. So in 1 day, there are 24 hours. Days cancel with day. And then we're going to go from hours to minutes. So in 1 hour, There's 60 minutes. Hour cancels with hour. And then in 1 minute, there are 60 seconds. And these are our conversion factors. That's what we're working with. So look, there's just ones on the bottom. So I don't have to divide by anything. I'm just going to multiply 2 times 24 times 60 times 60. And I get 172,800 seconds and 2. I want you to be able to set this up because this is the portion of the standards that we're working on. So I know that some of you can do it individually. Some of you will try to do it in your head. Some of you will try to just do it in a calculator. No, no, no. I want you to practice this. This is what I'm looking for. And then we're going to focus on getting the math type down when we get into Canvas. So there's going to be another video on that because I want you to play around with setting up these fractions, getting the multiply in there, and also I want you to be showing your units. So I'm going to show you what that looks like when we get into Canvas. Okay? But you need to be practicing this setup. And if I see units that are mixed up, I'm going to know that you weren't worried about canceling the units. You were just worried about getting that fraction on the paper. All right, so we're going to do some more conversions. We're going to change 5 feet 7 inches into centimeters. We're going to convert 13 days and 2 hours. Let's not do 13 days. Let's do 2 days and 5 hours into seconds. Then we're going to convert 12 square feet into square yards, and we're going to convert 9 cubic feet into cubic inches. So we're going to do all of those things. Now, why we're doing the first two is because we have two different sets of units. And so what we need to do is we need to focus on converting 5 feet into inches. So 5 feet we get multiplied by 1 foot is equivalent to 12 inches. So that would mean that the 5 feet is really 60 inches. But we also have the 7 inches, which is a different measurement. So what I'm going to do is I'm going to add that together with my 60 inches, and I have 67 inches that now I have to convert into centimeters. So it's like you have to do a little bit of a conversion, and then you're going to have to combine those same measurements, and then you got to keep converting. So now we're going to go from inches into centimeters. 1 inch, there are the 2.54 centimeters. So I don't have too much further to go. All I've got to do is change or multiply that by 2.54 centimeters over 1 inch. Inches cancel. So I'm looking for the setup when we do these types of problems. And 67 times 2.54 is 170.18 centimeters. I'm also looking for units. All right, we're going to convert 2 days and 5 hours. So that means I need to convert the 2 days into hours. 2 days and 1 day. There's 24 hours. Days cancel with day, and that means that in 2 days there are 48 hours, and you may already know that, but I still want you to practice that conversion. Plus the 5 hours means that we've got, what is that, 53 hours that we need to convert to seconds. So we're going to do in 1 hour, there are 60 minutes. I keep trying to put 60 seconds in an hour. And then in 1 minute, there are 60 seconds. Now, if you've picked up or you know that in 1 hour there are 3,600 seconds, you could use that conversion factor. But most people just go straight from the hours to minutes and the minutes to seconds. All right, looks like there's just ones on the bottom, so I'm just going to do 53 times 60 times 60 in my calculator, and I get, I'm going to write my answer right up here, 190,800 seconds. in my 2 days and 5 hours. So you can have mixed units, and that's the purpose of these two. It's just you're going to have to do a little bit of conversion, some combining, and then some additional conversion. All right, with the next two, they like these on the ACT. They like to give you square feet and have you convert them, or square yards, or cubic inches, or whatever to convert, because usually you'll forget things. Let's look at converting 12 square feet into yards. So the question is, how many feet are in a yard? And there are 3 feet in 1 yard. Okay, and here's where the issue comes in. This is not, let me circle this. This is not just feet. This is feet times feet. Okay, so let me get rid of that now. So this is 12 feet times feet, feet squared. Okay, and then when and now it looks like it's in a denominator. Hang on a second. Feet times feet. Okay, it's still in the numerator. When I go to cancel my units, which is why this is really important, I will only cancel this feet with one of those feet. So really, there is another ratio, another conversion factor that needs to be used, and it's going to be this 1 yard over 3 feet, so that this feet and this feet will cancel. And then look here, yards times yards is yards squared. So I'm going to have the proper units. But a lot of times what happens is people convert 12 square feet, they divide it by 3, that would be this 3 right here, and they would get what they'd say is 4 square yards, but that's not right, because they are really dealing with feet yards, which nobody deals with feet yards, but really you only changed one dimension, and this has 2 dimensions. This has area. Area has 2 dimensions. It has a length and a width. And so what you've done is you've only converted one of those dimensions, and you forgot about the other one, and so that's why this is a popular question on the ACT, is because you think you've done it right by only doing part of it. So I know that 12 divided by 3 is 4. I'm going to divide that by 3 again. We'll get 1.3, repeating 1 1/3 yards squared, or really 4/3 yards squared. All right, so we're going to convert 9 cubic feet into cubic inches. So this is the same thing. I'm going to write the cubic feet out like I did up here with the squared feet. Cubic feet means it's feet times feet times feet. Lots of feet. And I want to convert that to inches. So how many inches are there in 1 foot? In 1 foot, there are 12 inches. But this foot only cancels out with one of those. So I need to do another one. In 1 foot, there are 12 inches. Feet cancel with feet. Oh, I got to do one more. See it? This foot cancels with this foot. We're almost done with this slide. Hallelujah. And so, do you see this inch times inch times inch? That's going to give me my inches cubed. So, let's do 9 times 12 times 12 times 12. Now, if you wanted to do 12 cubed, you could, and then multiply it times 9. You could also do that. So, I, again, am on the wrong slide. I don't know what happened. There. Okay. So, I have, now I'm beating up my microphone, 15,552 cubic inches. Okay? So, it's all about units. All about units. It's all about setting things up. And it's also about knowing about, in this case, the square units and the cube units, what those mean, so you can set those up properly. But it's always, you're trying to look for units to cancel. And so if you're not writing units, you're going to have a difficult time. All right, let's try this one. I kept wanting to go back to it. So we're going to convert 500 meters per second into miles per hour. We're going to convert, let's see, $11.98 per pound into cents per ounce. That was the most recent steak price that I've seen. And Rita sprinted, let's see, let's have her sprint 100 feet in 4.2 seconds. How fast was this in miles per hour? We'll see. I just made these up, so she may be running really, really fast. We'll see. All right, convert 500 meters per second into miles per hour. So now what we were doing was we were changing one unit and into a different unit. Now we're changing, if you notice, we're going to be changing meters to miles. We're changing seconds to hours. So we've got these rates, and we're changing not just one unit, we're changing 2 units. Now that's probably the most that you're ever going to change. But what we're going to do is we're going to set up 500 meters. The per always means divide 1 second. Okay, so 500 meters per second. And we want to change that to miles per hour. So what we're going to do is we're going to pick one unit to work with. I usually pick the one on top, the meters. And my job is to change meters to miles. And then I'll worry about seconds to hours. You don't want to like lose track and lose focus. So, because you might get messed up. So what I know is that there are, let's see, meters to miles. I don't know meters to miles, but I can get from meters to centimeters. So in 1 meter, there are 100 centimeters. And hopefully, I'm going to probably try to write this kind of compactly so that I have enough room. And in 1 centimeter, nope, it's in 1 inch, there are 2.54 centimeters. In 1 inch, there are 2.54 centimeters. I'm putting that on the bottom because there's centimeters on top. 1 inch. Centimeters and centimeters. All right, now we're going to go from inches to feet and then from feet to miles. So in inches to feet, that's 12 inches in 1 foot. Cancel, cancel. And in 1 mile, there are 5,280 feet in 1 mile. So if I stopped and I did the math right here, I would have miles per second. But that's not what I want. I don't want miles per second. I want miles per hour. So that's where the units let you know you're not done yet. So I'm going to keep going. So I'm going to convert seconds, and you can seconds to minutes, minutes to hours. Okay? So in 1 minute, there are 60 seconds. Now, if you notice, seconds, they're on the bottom. So in this fraction that I built over here, I've got to put seconds on top. So I'm going to put, there are 60 seconds in 1 minute. And then there are 60 minutes in 1 hour. So 60 minutes, and I'm putting it on top because minutes are on bottom, and they're going to be able to cancel in 1 hour. Okay, so all of these units cancel. And if you look, what's left behind, I still have my miles marked. Here's my hours, miles on top, hours on bottom, miles per hour. All right, so then now what I'm going to do is I'm going to multiply. Remember, everything on top gets multiplied. 500 times 100 times, you can get the ones in there if you want, 60 times 60. So I'm going to do all of that multiplication, and then I'm going to divide by 2.54. I'll hit enter. Divide by 12, hit enter. And divide by 5,280, hit enter. So that's how you're going to stick in the calculator. 500 meters per second is 1,118.47 miles per hour. All right, let's look at converting $11.98 per pound into cents per ounce. So $11. Let's go ahead and do 12. Let's go ahead and do 12. We're going to do $12 a pound because I think I'm just going to focus on the dollars to cents and not that mixed ratio. So I've got $12 per pound, per 1 pound if you like. And then I know in $1 there are 100 cents. So that means that dollars cancel with dollars, and now I know how many cents there are per pound. But I want cents per ounce. Pound has 16 ounces. So I'm going to put 1 pound on the top, and 1 pound is 16 ounces. Pound, pound. And then now I have cents per ounce. And so that's, again, how the units can let you know whether you have the problem set up correctly or not. But you have to make sure things cancel. So I'm doing 12 times 100, hit enter, divide that by 16, and I get 75 cents, that's a cents per ounce. All right, here is where, remember we were looking at meters per second, 500 meters per second. This is 100 feet in 4.2 seconds. So you can still create a rate, a fraction, and do some conversions without, even though it's not over 1 pound or 1 second or anything like that. And we still want to convert to miles per hour. So I'm going to still need to pick. I'm going to use, I always start with the one on top. So I'm going to change feet to miles. Then I'll change my seconds to hours. So in 1 mile, there are 5,280 feet. And I put that there because feet on the bottom cancel with feet on the top. It's all about canceling. So now I've got miles per second. And then I'm going to convert my seconds to hours. So in 1 minute, there are 60 seconds. So seconds are on the bottom. I need 60 seconds on the top. 1 minute. Bam, bam. So now I've got miles per minute. And then I'm going to do 60 minutes in 1 hour. I think it's funny that you can, a lot of people run shorter distances, but we really only understand things in terms of miles per hour because that's what cars drive in. All right, 100 times 60 times 60, and then I'm going to divide by 4.2, and then I'm going to hit enter and divide by 5,280. 15.15 miles per hour. Rita's fast. She's not Usain Bolt fast though, because he's, I think, the fastest human. Okay. All right. Let's see what else we've got. Okay. Here are some where you can try it yourself. You need to pause the video and try to convert. Oh, we already did number 3, 500 meters per second. Don't do number 3. So we're going to convert $45,000 per year to cents per minute. So $45,000 per 1 year. And we're going to convert that to cents. So we know in $1 there are 100 cents. So that takes care of my dollars. So now I've got cents per year. And I want to change that to minutes. So in 1 year, what do I know about a year? There are 365 days. I know that. Year cancels with year. All right, and a day, I know that there are 24 hours. Day cancels with day. And in 1 hour, there are 60 minutes. Here, cents per minute. That's what I'm looking for. So I know I can stop and then just start shoving stuff in the calculator. $45,000 times 100 cents. Divide that by 365, divide that by 24, and then divide that by 60. And I'm doing them separately. So that means that you make 8.56 cents per minute. All right, a student ran the 50-yard dash in 5.8 seconds. So we're going to do 50 yards in 5.8 seconds. What speed did the student run in miles per hour? So I don't know how many yards there are in a mile, but I know in 1 yard there are 3 feet. And then I know that there are 5,280 feet in 1 mile. And these are ones that are stuck in my head. They could be stuck in your head too. All right, we're changing seconds to hours. I'm going to take a shortcut. You ready? there are, in 1 hour, 3,600 seconds. Seconds cancel with seconds. So I'm going to do 50 times 3 times 3,600. I'm going to divide that by 5.8, and I'm going to divide that by 5,280, and I get 17.63. Well, this student is faster than Rita. Miles per hour. All right, let's look at similar figures. Besides searching on the internet, what are some ways we could figure out the heights of these structures? We've got the Statue of Liberty. We've got the world's tallest flagpole in Sheboygan, Wisconsin. So if we weren't going to break out our super giant measuring tape or rely on Google to tell us how tall it is, we could do something like this. Now I have a similar triangles picture here, okay? And what we have is we have a tree, we have a person, we know the sun is hitting them at the same angle, we know the height of the man, and we can measure the shadows on the ground. That is something that's easy to measure. But if you're measuring the Statue of Liberty and climbing the Statue of Liberty, that's going to be very difficult. Even if you make it to the top and drop a measuring tape down, that's still going to be a difficult way to measure. So measuring shadows are easier than actually measuring a vertical structure. So what we're going to do is we're going to create a ratio, a proportion actually, of two ratios. And what we're going to do is we are going to compare the shadow of the man over the shadow of the tree. And I always do small to big. So the man's shadow is going to be smaller than the tree because the man is shorter than the tree. So I usually do the smaller figure over the larger figure. But it's going to be equally proportionate as the height of the man over the height of the tree. Okay, now notice that these two are about shadows and these two are about heights. Notice that this is about the man. Notice this is about the tree. If you don't set these up where the relationships are in the correct, not necessarily in the correct order, but there's a relationship between the stuff in the fractions. Each fraction, this is about height and this is about shadow. And then the numerators, there's a relationship. The denominators, there's a relationship. If you can get that set up properly, then all we got to do is cross multiply to solve. They're like these on the ACT, by the way. All right, so these little markings right here, these little apostrophes, those mean feet. So this man is 6 foot tall. He has a 5 foot shadow. So we have 5 feet to the tree shadow of 25 feet equals the height of the man is 6 feet over the tree's height, we don't know. But notice that we're going to keep the same units. These units match, so these units will match. Okay, and then we'll also play around with that idea when we deal with scale. We've talked briefly about cross multiplying. So we're going to multiply this way, and 5 times x is 5x. Multiply this way, we get 25 times 6. 25 times 6 is like 150, I think. Yep. Equals 150. And then we solve for x. Divide by 5. So the height of the tree is 30 feet. Okay, so setting up the proportion is probably of this the hardest part. You want to make sure you are paying attention to the relationships. I always do small part over big part, but that's just me. You can always do big over small. But you have to set them up to where you're paying attention to the relationships in each fraction as well as the numerators and denominators. All right, we can do these with shapes. And usually what we will do is I usually start with the small shape and then the big shape and try to find its matching side. You can pay attention to the letters, like PA is this side, and the first two letters WX, that's this side, and they correspond with each other like that. So I usually do the small shape, so I might do 17 over C, the big shape that matches with that side, and then these two would go together, and the small shape goes on top, 23 over, big shape goes on bottom, 115. So you can do these with geometry figures, and you will do these when you do get into geometry. So we'll get 23C equals 17 times 115 is 1,955. So C is 85. Now these don't have units. If they don't give you units, then you don't have to worry about writing units. But if they give you units, you should probably use them. So this one is a you try. Let me get rid of the ink, and you can go ahead and try it, and you can pause the video. All right, they look like right triangles. We don't know for sure. But this slanty side and this slanty side, those would be the pieces that correspond. So I could have small over big, A over 20. And then that would mean that I have 8 over 16, small over big. And I'm going to multiply. 16A equals 160. Divide by 16, so A is 10. And again, we don't have units. Now, some of you might have been able to look at that and be able to see that things are doubled, and yeah, that's okay, but again, we're trying to practice writing equations. All right, scale, it can be written a couple of different ways. But basically, scaling something means taking something from very, very big and making it small, or vice versa. Take something that's small and make it big. So blueprints are drawn to scale, especially of house like floor plans and things like that. Models are built to scale. So you can write them with colons, or you can see them like the bottom one, the 1/4 inch equals 1 foot. You can see that with equal signs as well. Sometimes they'll have units and sometimes they won't. The length of an object on a scale drawing is 2 centimeters, and its actual length is 8 meters. The scale is 1 centimeter to blank meters. So what we want to do is we want to figure out what the scale is. So what I can do is I can do 2 centimeters over 8 meters, and this is why I like to do the small over big, because it helps with scale. We want 1 centimeter over, we don't know how many meters, but notice the units. Now, before, all the units were kind of the same when we were looking at the other proportions, but here, this is going to be in meters. Now, don't get confused. It's not XM, it's X number of meters. So you can still cross multiply. So I can have 2 times X equals 8 times 1. And if you want to worry about the units, you can. In this case, because we don't have to worry about any unit conversions, we are going to be okay. So that would mean that 1 centimeter is the same as 4 meters. Let's see. Oh, I can move things. Look at that. I moved just the 8. All right, I'm trying to get this out of the way so you can do the you try. You go ahead and do the you try. All right, so we see that the scale drawing is 4 centimeters to 12 meters, and we want to know 1 centimeter to how many meters. Now, some of you can reduce that as a fraction, right? Because look at this. 2 over 8 reduces to 1 over 4, which is our 1 centimeter over 4 meters. So that is a true statement. Simplifying these or figuring out what the scale is just like reducing a fraction. So 4 centimeters is to 12 meters. 4 over 12 reduces to 1/3, which would mean 1 centimeter is 3 meters. So there is that relationship there, and that's why at the beginning of the video I was talking about how ratios were related to division. Alright, the length of an object on a scale drawing is 1.5 inches. The scale is 1 inch to 6 feet. What is the actual length of the object? So we know that we have 1.5 inches, and we know that the scale is 1 inch to 6 feet. I just don't know how many feet the actual object is. So here's my scale. I set up my scale. This is kind of the backwards of what we were doing. Before we had both of these measurements and we were looking for part of the scale. Now we have the scale and we're looking for the measurement. So again, I do little over big, or the drawing over the actual object. I'm going to cross multiply and get x equals 1.5 times 6 is 9. So it's 9 feet. All right, so you have an object. Can you figure out what its actual length is? All right, so we have 2 inches, but we don't know the feet. We do know we have 1 inch to 4 feet. So that's going to be x equals 2 times 4 is 8. 8 feet. All right, these are equations that you're solving for a variable. A lot of people don't like them because not only do we not like fractions, we don't like variables in our fractions, and we don't like more than one fraction to begin with. So here's the key idea. I want you to wrap either a numerator or a denominator with 2 terms. Most of them are going to have 2, but you could have more terms. 2 or more terms, but I'm going to stop that at 2 for us. With 2 terms in parentheses. That's the first job, like the first step of this. So here in the left one, bam, that's step 1. Here in the right one, bam, that's step 1. That was the easy step. Step 2, cross multiply. You may be able to distribute, and then you're going to solve your equation. Okay, so let's do some examples. So if I multiply, cross multiply, 6 times 5 is 30 equals, when I multiply this way, I have my parentheses already there, so I'm going to do that 3 that's from the top right, and then parentheses 3b plus 2. Okay, what that does is it gets everything on one level. Now I can distribute, or if I wanted to, I could divide by that 3 that's out in front, but I have 30 equals 9b plus 6. Subtract 6, so I get 24 equals 9b. Divide by 9. So you're solving your normal equations. Now that reduces, I can divide the top and the bottom both by 3, so that's 8/3. But to go from here to here, that's the part that we're learning. The rest of it you should know how to do. That's your multi-step equations from lesson 1. It's just getting it out of those 2 fractions. So lots of fraction work today. So 6x equals 4 parentheses 3x plus 2. All I did was cross multiply. I'm going to distribute 12x plus 8. I'm going to subtract 12x. Negative 6x equals 8. Divide by negative 6. X equals, it's going to be negative 8 divided by 6 is 4/3. All right, so there is some U-type problems, so you can go ahead, try these. Pause the video if you haven't already. All right, you're back. Your first step. Bam, 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 bam. We have 2 sets that need parentheses. We're going to cross multiply. That means we're going to have a lot of distributive property. All right, so 3 times 4 minus f equals 5 times f plus 1. Then we're going to distribute 12 minus 3f equals 5f plus 5. And then we're going to move the 3f. Now, I'm going to go ahead and do this, and some of you have already been doing it, but we're working on getting better at our equation, so I'm going to throw an extra piece in there. So we've already moved the 3f, the negative 3f over. You could, in the same fashion, go ahead and take care of your constant and take care of that piece over there. Now, if that's too much for you and you need to do them in separate steps, okay. But you can, I usually start doing that when I start running out of space. It's a space issue for me. But remember, 5 and then a negative 5, those are going to become 0. Negative 3f and positive 3f, those are zeros. So make sure that you're doing that properly. All right, so f is 7/8. All right, over here, I'm going to switch to blue. Bam, bam. First step done. Woo! All right, we're going to cross multiply. I'm going to do 5 times 2x minus 3 equals 2 times 7x plus 4. Now I'm ready to distribute. 5 times 2x is 10x minus 15 equals 14x plus 8. Then I'm going to move this over. That takes care of that one. And I'm going to add 15. I'm doing that kind of combining steps, but not. It's like, again, it's saving space. 10 minus 14 is negative 4. 8 plus 15 is 23. I'm not going to be able to reduce that, so I'm going to leave it as negative 23/4. Hopefully you are getting better with your improper fractions. All right, guys, enjoy working with lesson 5. See you later.